All right, welcome back. We are Game 2014. That's Mobile Game Development 1 in the fall 2021 semester at George Brown, and it's week 9, part 1 of our broadcast. And let me just put this video on Blackboard for us. So we're ready to go, and we're good to go with everything else. So under the content area, right, of week 9, we're going to have that new video, which is just going to be a web link because we found that, again, making the video work in other ways doesn't seem to work nicely with, or play nicely with Blackboard for now. Could be Blackboard's issues. All right, so there it is. So for people who need closed captioning support, it's up on Blackboard. All right. Let's move into the next part. So again, we're sitting at week 9. And a couple of things that we're going to be talking about today is rigid body physics, and our lab is all around getting player motion going today, as well as a couple of things I want to talk about is assignment 2, part 1 and part 2, and what that is, right? So again, they've both been released. Part 1 is due week 11, and part 2 is due week 14, and I believe that's November 24th, which is when part 1 is due, and December 12th for the second part, okay? We're also going to be talking about the 3 C's of character design, camera, and controls, and the nuts and bolts of mechanics with something else called a platformer primer, which is something we're going to be covering as well. So kind of cool. We're also going to be covering tile maps, which should be a review for you. If you've done something with tile maps and with JOS. Did you guys do platform or tile maps with JOS, guys? Yes or no? Yes. So this is kind of a review of that. So that's what this is. So a review. And touch input revisited, and we're going to talk about rigid body physics and making that work. All right, so that's what's coming up right there. But before we get to this, let's talk about our first topic, which is our assignment to part 1 and an assignment to part 2. So we're going to go into that first. So I'm going to bring up assignment 2, part 1. Well, in this assignment, this is the second game you're building for this semester, and this is a platformer. So there's not a lot of options here. Either it's a platformer or it's a platformer. There isn't another type. And the first type, you had a chance to make a 2D top-down shooter or some kind of top-down scrolling game or something like that. Here, it's literally just a platformer that you're making. Now, there's different kinds of platformers. There's a puzzle platformer. There's a regular platformer. And that's okay. But for the most part, you need to know 2 things. One, it's in 2D. And the second piece is it's a platformer. That's it. Okay. Again, the first part is due November 21st. And just like before, this is a 2-part assignment. So the first part is planning. The second part is logic and making everything go. So same as before, you're making a 2D platformer with Unity. You must use Unity. You're going to have a menu screen, an instructions screen or screens. We'll talk about that in a bit. A gameplay screen and a game over screen, some kind of scoring system. And you're going to have graphic and sound assets of your own. You're going to be using the C# programming language, and you're going to make a short demo video to demonstrate everything. You're also going to have a game design document that you're going to create specifically for this assignment. And so again, menu screen to make it go. Instruction screen, one of the things that we have when it comes to instruction screens that I have to mention this time around is there are 2 types of ways of tutorialization. One way is some kind of swipe instruction screen where you swipe to the right and then you get to the next instruction, the next instruction. Be clear that most times for most games, you'll need more than one instruction screen. So I say instruction screen, and really what they should say is instructions screen. You know what, you want to create one or more screens that will display rules and instructions on how to win the game. And so what this is more than one screen a lot of times. Why? Because you should really limit your instructions to one instruction per screen. So one mechanic or something like that per screen that you include. Okay, one and only one. And that's one way of doing it. The other way of doing instructions is doing a tutorialization, some kind of tutorial level. So I will also accept, instead of an instruction screen or screens, a tutorial level where you might have a guide character, someone who is an NPC, an on-player character, who is going to guide the player through how to play the game. A lot of times this is another way of doing it. You might have an NPC that says, hey, press over here, do this, attack with this, pick up the sword, and do that kind of stuff. And that can replace your instruction screens for this assignment, if you will. Not for the first one, or if you want to. So for the first one, I said you must have one instruction screen. This time, yeah, I'm giving you the option of adding more depth and adding more instructions than we had before. Gameplay screen was where all the game happens. For here, you're going to get all the assets. So what I want you to do for this assignment is every asset that you can get for your game, I want you to get them all. And I want you to put them in a static pose in the level, just like we did before. In this case, you're making most likely a use of a tile map or several tile maps, a couple of tile maps, maybe one for the background, one for the foreground, maybe one for the death plane, and a bunch of other stuff. So that way the game itself that you're going to be creating is going to have one or more tile map graphics that you're going to use. And you're going to position everything. You're going to kind of build out your level from the beginning to the end for the first assignment. Okay, so build it out. Now, it doesn't mean that you can't change it or modify it, but I want you to have a general shape of what the entire level is going to look like by the end. Next is your game over screen. We know what that is. And the player will control an avatar. Again, the avatar is going to be an item that has a rigid body, right? And here's something, you must include platforms. Yes, it is a platforming game. So platforms that the player can jump on, as an example. There must be platforms. And the platforms can be different kinds. So the player's avatar will be able to move onto or over these platforms with use of a jumping, falling, bouncing, spinning, swinging, or other movement mechanic of your choice. Whatever you want to do. You can also do other things, like some people use teleporting. Some people use a backpack or jetpack. Some people use a grappling hook mechanic where they get to the platform through the use of a grappling hook. Okay, so they kind of pull themselves underneath one platform and then they let go and then they drop onto the platform that way. So there's no jumping whatsoever, or they might be jumping with the use of some kind of springboard, as an example, as opposed to so some kind of bouncing mechanic. You must choose at least 3 other platform mechanics as detailed in the platformer primer section of your class notes from week 9, and that's this week. And this may include, but is not limited to, platforms that float, move horizontally or vertically, flip, explode, tilt, bounce, tip, collapse, swing, grow, etc. And for this assignment part, you should place these special platforms in the desired locations in your game. So you need two types of platform: a static platform, maybe where the player starts, and some dynamic platforms that you're going to program. Okay, your game will include enemies or hazards, or hazards, is what we should probably say here, with simple AI behavior, line of sight and/or detection radius, as well as simple steering behaviors or movement. The enemies or hazards in the game should be abundant enough to challenge the player, but not be impossible to beat, just like before. One thing that we had in some of your submissions for assignment 1, part 1 and 2, is some of you, for whatever reason, although I said this at one point, is made your game faster and faster. And that is not a great mechanic unless there's some way of making your game slower and slower. So in other words, like it speeds up, but if you do something, then you can slow the game down so it's doable. If it just gets faster and faster by playing an endless mode, that's not a great way. It's not really replayable as much. It's kind of an annoying mechanic more than anything else these days. It's kind of very old school. Doesn't really work these days. Random opportunities to generate points to the player. So some kind of treasure pickup or other kind of power-ups or something else you want to choose. Scoring system, health system that we talked about before, some kind of sound effects, and game soundtracks. That's it. Same kind of idea that we had before, but this time we're doing a platformer. Gives you another chance, kick at the can, as opposed to a just some kind of scrolling game or an arcade game. Some people made Pac-Man. I had some other people make, they remade Space Invaders. right? Again, this isn't that kind of game. This is a platformer. Internal documentation, you guys should know now how to put together your internal documentation for your program. You add a script that's pretty much empty to, let's say, a player behavior script to an empty object, could be the player, the representation of the player, and just add in details about who you are, your student ID, your the date last modified, and the program description, what this thing is about, and all that stuff, at least to one script in your game. You can also add information like this to your README file, but you need both. And then your first draft of your game design document, you've done a game design document in the first half, you're going to do another one. So another set of practices for your second half. Think about your interface sketches. Some people didn't do a great job of this in their game design document in the first half, where they didn't, either they missed this component altogether, or what they ended up doing with their sketches was very basic and really didn't describe what they were making at all. All right, so again, these things should be descriptive enough so when I look at it, I'm like, okay, I get what they're making, right? Screen descriptions are some initial screenshots of your game based on placement of your of the stuff in your level. Describe your game world, levels, characters, and vehicles, all the same stuff that we had before. GitHub is going to be used for version control, but some people have asked for other kinds of repositories. Can I use GitLab? Can I use Bitbucket? The answer is yes, as long as you include me as a collaborator, if it's private. And some also, just on that, what I want you guys to do when you share your repository with me is please use my last name at hotmail.com, right? So that's my general inbox. That's my the account that you can use. But if you use the other one, there's two accounts on GitHub. You'll see me and me. Include me both. Like invite both of them to your repository. So I'll get two emails, but at least this way I can access the repository. Some people only add one of my accounts, but not both, and they add the wrong one. I get it. It sometimes can be confusing. Please add both, or else I won't be able to access your GitHub repository, and then you won't get marks for GitHub. And then make a short video as before. It should be very straightforward because all you're demonstrating is what you're making. Talk about it. Say, hey, this is the game that I'm making, kind of thing. And here's my mechanics. These are the platforms that I'm thinking about using, and so on. Describe your game a little bit for me. 5 minutes max. Again, it shouldn't take you that long. And same kind of rubric as before. So that is part one of your second assignment. Assignment 2, part 1, again, is due Sunday, November 21st at midnight. What about assignment 2, part 2? Let's go there. Well, assignment 2, part 2 is just a logic piece for your game. So basically, everything that you planned in assignment 2, part 1, you're actually going to make work in assignment 2, part 2. So we'll say one or more. We'll say that create one or more, or we'll say one or more instruction screens. We'll display rules and instructions on how to win. UI element will allow the player to transition back to the menu screens, or we'll say UI, one or more UI elements will allow the player to transition back to the menu screen. Sound effects of the player's selections and music of the scene should be included because you're going to make sound effects that are different for the instruction screens compared to everything else. Again, you can replace your instruction screen requirement with a tutorial level if you're interested in doing so. And this would be good because, again, you could have a guide character, an NPC that kind of guides the character through how they're going to play the game. Some kind of gameplay screen where you give the ability for the player to move and navigate through the world. A game over screen, and the player will have control of an avatar. What I talk about here is you need to use rigid body physics. The game must include platforms. Rigid body physics, collision detection, and response using a game engine is what you need to use. And you must choose 3 other platform mechanics as detailed in the platformer primer, which is in our class notes. Okay, so enemies are hazards. Write code so the pickups, treasure, and loot is randomly generated. And you're also going to include a scoring system and a health system for your game, as well as sound effects and soundtracks should be activated and working. Internal documentation is more complex because you're going to actually have functioning classes you're going to have to add some more documentation to. And for your second and final draft of your game design document, update your version history. Ensure you update your control scheme here. Sometimes we learn stuff by putting stuff out in the first version. We play with the control scheme and so on and figure out how we're going to do things. And updated screenshots. Sometimes we have a plan of what we're going to do and an actual that we get to in the second half. And so these might be different or updated compared to the first versions of your game design document. What do the levels look like if you have more than one level? And as well as enemies, what do they do? Have you changed them? So this is kind of an update or a final version of your game design document. GitHub as before, short video as before, and that is your second requirements. Again, this one is due December 12th, the final version. So you have really until December 12th to get them both done. But the first one is due November 21st. That's 2 short weeks from now. Wow, I can't believe that because we're sitting at week 9 and it's due week 11. Yeah, 2 short weeks for now on the Sunday. So it's always due on the Sunday. So it's kind of like a week and a bit, week and a half from where we sit today. All right, questions around your assignment 1 part 1 and assignment 2 part 1, assignment 2 part 2. Herman, why are you saying rip? Is it because you're worried about the amount of work that this is? What are your thoughts? I know that you guys had no rest, not really a lot of rest in your during the break because you had some stuff to do for Joss as well. And that could have been very challenging. But what about, how are you feeling about this one? Are you guys okay with this one? I'm going to take that as a yes. And I'm just going to check on YouTube to make sure that there's any comments or questions there as well. All right. So, yeah. So that is your assignment 2 part 1, assignment 2 part 2. Again, do week 11 and week 14. Second, kind of application you're running or writing this semester. All right, let's talk about design a little bit. We'll talk about the 3 C's, nuts and bolts and mechanics, and the platformer primer. So what are the 3 C's of character design? Character, right? 3 C's. By the way, one thing to note also when we look forward is that there is a test, a theory test, a little quiz on platforming that is going to be coming on the week 12. Again, we'll be doing it simultaneous with our scene management and building for mobile that we're going to be talking about during that week. So we still will have lecture, but there'll be a quiz that'll be due at the end of the week. Okay, again, you'll have from the beginning of the week until the end of the week to get it done. So let's think about this. Again, when we think about pre-production, we plan 3 things a lot of times: how our camera works, how our character works, what is our character, and what are our controls. These 3 things. If you change any of those 3 things during your production, you can really have a lot of rework to do because of the changes. Imagine changing your character after pre-production. You plan your character, you think about what the character is going to be, and all of a sudden, bam, you change your character to something else. Or you change your camera. Instead of a third-person perspective camera, you're going to go to a first-person perspective camera or something else. It can be massive rework. Same thing with control schemes. One thing we want to start off with is the idea of character. And I think some of the wisdom that we're going to get here is form follows function, where when we look at a character, we want to look at their silhouette, okay? The silhouette itself, again, from professional character designers, the silhouette speaks to you or informs the player about what type of character you've got there, okay? And we'll talk about character. So character, we're going to talk about what kinds of characters there are, but first, the shape of the character is really, really important. Again, we're talking about design for a second. So when you pick your assets, think about the design and what kind of character you want for your game world. What's the narrative? What's the reason why the player is playing the game in the first place? So again, it tells us what the character's personality is at a glance, helps us distinguish one character from another, whether it's an NPC or the main character or whatever, helps identify friendly or enemy type characters, and helps characters stand out against the background and world elements. Right, there's a difference. For example, take a look at these silhouettes from Team Fortress 2. They're all very different. and they all have different meanings depending. Just looking at the silhouette, no details. Silhouettes can mean a lot. Next step is really understanding that there are just three types of characters in video games for the most part: humorous characters, heroic characters, and some kind of tough character. Okay. And again, I know this is simplification because you can have many different archetypes, but when you think about them, they fall into one of these buckets or categories. And there could be other ones that you can see as well. Humorous character says funny things, does funny things, looks funny or cute, right? A heroic character might be doing heroic things, is always good at something, some kind of specialty that they can do, like a perk. And you can decide at the beginning if you want, and can come in all forms, right? A tough character usually does some hardcore things in style, right? They're not quite a nice person. I'm thinking the hardcore tough character from the Doom series. Not really a nice person, but they say cool things and they almost never shout, and they look like a bad guy or gal, but they act mostly like a hero. So they do good things, but they act kind of bad in doing that. Again, I'm thinking about Doom, right? Where the character's not a nice guy or at all, actually. And or Duke Nukem as an example, where Duke Nukem says really bad stuff, right? A lot of times, but he's there to sort out the bad problems that are happening in that world, right? So tough character. And there's also games without characters. For example, the guide character, which is like the narrator. We talked about the guide character, narrator, a host, an MC, an NPC that's going to add tutorialization. So almost like a NPC that provides guidance, right? That's what it does, through a tutorial. All right, and the story is the guide. So that's the other one. So in other words, the story is the character. So puzzle games that tie levels together through some kind of story in the background. And the world is the character. So where, as an example, you might have a construction management type of game, and the world itself is the character. Other kind of games that this might work well with is some kind of tower defense games. All right. So that's kind of an example where the world is the character. There is no actual character. You're actually controlling the world some way. Construction management, a social game, or a simulation game. Like, example, it might be like, I'm simulating the city. The city itself is the character, right? That I'm kind of using, as opposed to a specific character themselves. So non-character type games. Let's talk about gameplay. Now that we know about characters, we can think about gameplay itself. So when we create a character for a platformer, so a character that has a personality, we can think about them in terms of height, width of passage, walking speed, and running speed. So we start designing our character. We think that the width of the character makes sense. The height of the character is important, because we're going to use the width and the height for things like our walking distance, our running distance, our horizontal jumping distance, our vertical jumping distance, because they all have to be relative to the size of the character. Melee distance as well as projectile distance. These are all things we're going to be talking about based on height and width of the character, okay? Other things to think about is the jump distance. Sometimes what happens is you have a character, and in real life, we might only be able to jump to about half a jump in real life, right? Doing a whole jump like we expect for a character to be able to do, as an example, is kind of like based on the character's height. So I want to be able to jump like my entire height. That's a whole jump. And sometimes we want to be able to do a double jump. A double jump means we jump once and then click the button again, or press the screen again and jump again, right from space, like, if you will, right? So a double jump. Or sometimes if it's a long press, we can actually jump twice, like twice as long. In real life, even this, the whole jump would be mostly impossible for most of us, unless you're some kind of star athlete playing basketball or something like that, and already quite tall. A whole jump is really difficult to do in real life. And a double jump would be really realistically impossible, right? Unless you're some kind of superhero, which most of us are not. And the same thing goes with what this informs us, right? So if I do the jump distance itself, we can use the double jump a lot of times to look at a cliff or some kind of platform and say, players will learn that they can reach anything up to double their own height max. That's kind of, we can do a double jump. And but when it's higher than double our height, typically up here, right, as an example, they will learn that they can't get to this elevation, so they will look for another way to reach it. And this is an important thing to do. So figure out how far your jump distance and jump height will allow. So maybe the maximum jump height is the double distance, okay? Without doing a double jump. A double jump, we'll talk about jumping in a bit, might be jumping this and then jumping this again. All right, so a double distance, double jump, kind of thing. And we'll talk about that. Melee attack distance, usually the extent of the character's arms, as an example, will be the place where they can start hitting another character. Whereas the projectile distance, there's two ways of doing this. One is it could be the character's reach as well, right? Or a lot of times the width to as far as the character can see within the game world. So for example, in this case, the screen itself, the camera is following the player, or it's not following the player. This is what the player can see. Anything outside of this, the projectile is lost, right? Other things that may happen with projectile distance is when they hit an object that looks like it should be hit, the projectile is absorbed or bounces off. It depends on how you want to do it, but that is the projectile distance. Again, all part of your mechanics. How about the idea of the jump? All right, so the jump is really the most difficult thing to pull off properly in a platformer, how we do the jump. And there's different types that we're going to talk about. One of them is the single jump. So the player jumps once, either vertically or horizontally, and they're going to jump double their height typically. That's typically how we can jump, double your height. The double jump, a second vertical or horizontal jump that starts while the player is in midair. So you kind of jump once, press the button again while you're in midair. You can jump a second time, right? And that's okay, right? When you're at the top of your jump or partway through your jump. The triple jump, where you're jumping up and you jump again and then you jump a third time, okay? A lot of times though, the triple jump happens when you're bouncing off something else, as an example. So you've got some momentum, and the same thing with a double jump. You can double jump by hitting something else. You jump once, you jump on the wall, which is kind of like wall jumping as well. We're going to just talk about that in a second. But typically these are the three mains. A contextual jump, which is like an automatic jump. So you kind of approach some kind of springboard, or the edge of a ledge, and then instead of you controlling the jump automatically happens. Your game controls the jump. It takes away your jumping capability from you, so you can't really fall, necessarily, unless it's a mistimed jump, right? So it's a contextual type jump. The wall jump, where you jump on, and we're thinking about something like Super Meat Boy or Ratchet and Clank, where you kind of connect to a wall, and then when you hit a wall, it allows you to press the space bar again, or press the screen again, and go to and kind of jump in the opposite direction, right? And keep on doing that over and over again, so you can kind of navigate the world in a vertical fashion. So from the bottom up, as an example. What about jumping? Well, jumping has an idea of something called the jump zone. So the jump zone is going to happen where you want to initiate a jump somewhere that's safe, usually not at the edge of the ledge. You don't do it here. Okay, typically we don't do it here. And we don't do it way back here because this is too far, right? So we do it somewhere in a sweet spot where we can get enough momentum so we can kind of get to the next ledge, as an example. That's usually what happens, all right? And what we want to do is we go to, we land. When we land again, we want to land in the sweet spot again. We want to make sure that the player has a little bit more comfort. So you don't want them to be able to land there. If that's how you've planned your world, that's not good. So space out your platform so that the player, when they jump, will so it's not just random placement of platforms. They're going to jump here, most likely. Okay, they're not going to jump here at the edge of the platform or here. because this is very dangerous, doesn't feel safe for them, especially if there's momentum or any kind of sliding. They can slide right off this and fall to their death. All right, so you want to give them a chance to feel comfortable when they're jumping for the most part. Sometimes, though, part of the challenge is making platforms too small, so that way the player will have to jump or time the jump exactly so they can fall in the right place. It really depends, Herman. So, example, you want to, what I'm saying is you want to make a zone. It could be the edge as well, but it could, you want to make a zone where the player is going to feel the safest to perform their jump. Okay, something like, and you don't have to mark it, but something like, here's the jump. This is where I'm going to jump from, and this is kind of where I'm going to land. When you make your game, when you plan your levels, make it this way, right? Is what I'm saying. The other thing is falling down. So what goes up must come down. So again, when you think about this, falling, if you fell to a height of this, you'd be okay, right? But anything more than twice your height, you're gonna take damage, right? This is not a good scenario, right? So that's not something that you want to be able to do. Remember that you can always, if you're falling, would you allow things like jumping in the middle of your fall? So having this jump thing happen, this is also something that you may want to enable as one of your options. What about this? What about if I fall, but I turn around, am I going to allow the player to hook back onto the wall and somehow climb back up? Is that a mechanic that you're going to allow off the platform? So falling is also there's a lot of nuance to falling as well. Okay. All right. So falling and jumping. All right, any questions around the player, the character, movement for the character? And we talked about a bunch of stuff here. How far the player can run, as an example, which is the walking speed, and the running speed, which is about twice the speed, usually more, little faster than that. The horizontal jump distance and the vertical jump distance, you should have these mapped out nicely, and these ones should not be random. They should be metered, if you will. They should be calculated and be precise, right? The more precise these things are, and not based on the players, how long the player holds the space bar or holds the screen typically, right, is the way it goes. And that is your mechanic. You want them to hold or gather energy before they jump to the up or across. All right, let's talk about the camera, right? So we talked about the character first. Now we're talking about camera. So again, nothing was going to kill a game faster than a bad camera. Let's talk about a bunch of different kinds of cameras that are typical. One of them is the static camera. So think about this as a static camera where in a platformer, the player can walk around and the camera doesn't move at all, right? That is an option. And then when a player moves to the edge of the screen and they're going to go to the next platform, then and only then does the whole camera move over to the new screen. It's almost like your level is divided into a series of screens. Sometimes people use multiple cameras. And so what ends up happening is you transition from one camera to the other, almost like your game world is being looked at by multiple cameras. And when your player enters the new camera, that camera turns on and the other camera turns off. There is no smooth transition. It's just a static camera or a series of static cameras that happen. Okay. So again, you got to think about this, that the scrolling camera at the time where static cameras were used were not invented yet. Sometimes there isn't even another part. You can't even leave your screen. And I think about games like Donkey Kong or other Mario Brothers type of games where you're just like literally locked onto one screen. Think about the arcade where you're on one screen. It's kind of you're platforming vertically. You're going up vertically. You're not going across horizontally in any way. And it's only one camera. There's nothing else. Doesn't move. All you're worried about is player movement. The other one is the scrollable camera where my camera follows the player. So it's different than the static camera in that the movement, it keeps the players engaged. So I'm moving from one place to the other. I'm able to reveal things that are off screen, so I can surprise the player with things that they cannot see in the single screen that they're looking at. And there's different kinds of scrollable cameras. For example, when do we turn the scrollable camera on? Do I want to turn the scrollable camera on right away? Do I want to give a threshold where the player can move before I turn the camera on? the scrolling, right? So I can give a player more movement within the camera view until they hit some kind of threshold. Example would be they move, kind of towards the right of the screen, then the camera moves with them, as opposed to the camera always following, a direct follow, right? So we'll talk about techniques like that. And one of the things we use is Cinemachine. And I'm sure that if Joss hasn't talked about camera before, it's definitely something that we do in platforming. Parallax scrolling camera. So again, the world moves with the camera as an example. So the camera, here's the camera itself, but in the background, you have some kind of one or more layers in the background that scrolls. And it gives a sense that the background of the world is deeper or has a three-dimensional depth. And this is further exacerbated when you have different layers, a multi-plane camera, where you have different layers that different things live within. For example, you might have enemies on the front, or the back layer, or things that you can't be affected on, and maybe even the ability for you to switch axes. So I can go kind of somewhere far away or come forward to give your character a sense of depth. Sometimes it's used, for different effects. For example, I want to create a paper 2D kind of world, and I want to be able to switch between layers, and I've seen games like that as well. Okay. Then there is the first-person perspective camera, again developed back in 1992. Wolfenstein 3D and Doom in 1993 were the kind of the two games that really took advantage of the first-person perspective game in the 90s and late 80s actually as well. And this is a very popular mode for 3D games. We're not playing 3D games again in our case. There's also before that there was games where we had a first-person perspective mode, but it wasn't true first-person perspective. It was a faux first-person perspective mode, right? Which was kind of being generated for you as you're moving through the world. The other one that's more difficult than first-person perspective, we're going to explore this next semester, is the third-person perspective camera. And the reason why this is more difficult is because you can have, the challenge with this is the camera can be occluded or blocked by something that's between the camera itself. Let's suppose I have a camera over here, let's say. So here's my camera, and it's looking at the game world. It's looking at the game world. Just going to use the annotation here just to make it so it's simple. So here's my camera, right? And I'm looking at the game world, but maybe if there's something that's blocking, so between the camera and the game world, right, itself, so let's say here's the camera, and between the camera and the player, there's something else, then I won't be able to see my player. Example, it could be an enemy that's in here, or a wall, or another obstacle, a prop or something. You need to figure out what you're going to do with this camera. And some of the things that we do with the camera is we use a colliding system or collision system that allows the camera to move, zoom, do different things with the player. Or we use transparency, so we kind of turn on anything that's between the player and the camera, so including the player, will be made semi-transparent, so we can actually see the player at all times, right? Sometimes it's the other way around. The player is made transparent if they go behind a wall when the camera's looking at them, right? So that is also another technique that we use. For third-person perspective, it can, yeah. Cinemachine can deal with it as well, absolutely. But I want to point out this is an issue. If you're going to program this, let's say Kira, in a C++ type game, you'd have to deal with that yourself. How do you do it? Right, so you have to turn on or transparencies or whatever. Here in Unity, yes, there's a lot of automatic stuff that happens for us, so we don't have to worry about this in 3D. The other one is the 2.5D type camera. 2.5D cameras gives us a sense of third-person perspective, so almost like using a 3D character in a 2D world. Games that remind me of this are things like not just Crash Bandicoot, but other games like even Diablo. If you think about it, we have a 2D perspective game or some kind of isometric, game. Here's another example, an isometric type game where we have 3D scrolling in a 2D world, right? Both these type of schemes provide different depth to provide another view at the world. So whether it's isometric, 2.5D, or if it's just using a 2.5D camera with a different look, almost like the game is on rails, which is what happens with Crash Bandicoot, right? It gives us this some movement up, down, in, out on the Z-axis. Again, similar to what we could do with this idea of a multi-plane camera, where I can actually move the camera, the character in the Z direction and out again, but only in steps typically, because it's still a 2D character, right? So those are other kind of schemes that we can use, almost like this 2.5D world. The other one, which is what you guys may have seen from last semester, or sorry, from the last assignment, is kind of a top-down 2D world, which is kind of old school. And what it does is it's like a gauntlet kind of game, or a top-down dungeon type of game, or some kind of a maze type game from the top down, or top down, any kind of top down game, which is a different kind of perspective for the camera itself. So that's kind of covers most of the cameras that are out there. Any questions around camera? So you're gonna have to pick one for yours. I recommend, again, some kind of follow cam. A scrollable camera is a very common way of doing things with platformers. But again, it's up to you if you want to use something special to create a different mechanic or different view on your game world. Part 3 is the controls. So we talked about character, we talked about cameras. Now we're going to talk about controls. How do I control the game, right? Well, we control it typically, if we're not talking mobile, we're talking with some kind of controller, right? I have a gamepad or something else typically, or keyboard and mouse combination. And I want to support both in the tech demo that we're going to be doing today. So we're going to first start off with our typical mouse keyboard combination, mostly keyboard. And then we're going to actually also include touch, and how can that work for us? Touch input compared to basic, basic other kinds of input, right? Which is the WASD kind of input. So, but when we do touch input, because our fingers are great kind of inputs for us, right? We can do a tap, and a tap typically means a quick press, right? That's used to make some kind of selection or make a character perform an action, like shoot a weapon or quickly place an item. A double tap, a lot of times we want to open and close selection windows, and indicates a direction for the player to move. So if I double tap, one of the control schemes without using some kind of virtual controller is, if I double tap, it places a waypoint for the player to travel to. And so then the player travels to that waypoint and stops, right? So there is no, but that means that while they're traveling there, I'd have to double tap again to reverse their direction or to do something else. A timed tap, where maybe I want to tap on the world, but I'm going to ignore the other taps that are happening, and I'm going to wait for a specific moment, as in a rhythm game, for the tap to be valid. If it's not, if I tap any other time, what's going to end up happening is it's going to fail. It's going to create an invalid tap, right? If I'm not tapping in the right rhythm. And a touch and hold. So if I want to hold a moving object in place, right? Touch and hold. A hold and drag. When I want to move around inventory items, dressing characters in their finest armor, all that kind of stuff. A flick could be something like I want to throw something at an enemy or something like that. Might be really cool. A page up or page down is another flick, but it's longer, right? Where I want to flip up or flip down, or flip across if I want to take a look at documentation. A lot of times we talked about the flick across as more of a swipe, which is what we talk about here. So we can do things for a bunch of things that we want to do here. I want to do swipe from right to left, where that usually means delete an action or undo an action. If I'm planning a game, from left to right, if I want to remember something or I want to move to the next screen, go right to left, move back to the other screen, as an example. Or sorry, right to left moves to the next screen to the right, left to right, move my screen to the right, so it goes back to the other way. Pull and release, as in something like Angry Birds, where we kind of use the game's physics and we create some kind of feedback for the player, so we can make them hear and or feel with haptic feedback that they're pulling down some kind of thing like an elastic or spring, and that it's going to propel an item, the player, something else in the opposite direction. Scrubbing, so I want to scrub something across the screen if I want to erase something with a sharp back and forth motion. Okay. I can also do things like shape drawing if I want to make some games will allow you to do that. Shape tracing and a swirl where I draw something in circles. All right. So sometimes all those things can have meaning in the game world. The other way to do it without touch is using something called a virtual controller. And you can download, one of the things I will allow you to do for this game as well as for next semester is download a virtual controller or gamepad. And we'll talk about how to do that. And what it does is it creates a graphic on your screen, a joystick, if you will. And that graphic on the screen will allow you to control the player, where you have a kind of a circle that gives you an indicator of where to go, some arrow indicators to the right, left, up, and down. And then you can have some kind of control to move you around. One thing to also note is I want to just kind of on a side note, if you bring up LD Player, I'm just going to use a game that I downloaded from the Play Store called Exiled Kingdoms. Again, not the most amazing game, but it is a mobile game. And it's not a platformer, but rather it is a regular kind of RPG type game. Notice the controller on the left-hand side, right, where you have a virtual joystick here that moves all around. Now here, even though it's not a platformer, I can move my character around in 2.5D, right? And until I get to a point where I want to interact with an item, right? And when I do that, I can look at the inventory items. Again, this is all through touch, right? And I can move to the right, to the left here until I get to the next part. And every time I go there, there's something that's giving me some information about what to do, where I can fight with a goblin or even use a special attack. Okay? So that's kind of the way we can do it. This virtual kind of control we can use to, you know, spam the keyboard and do whatever we want to do. So that's kind of what I wanted to talk about there. So that's what it would look like. So some kind of virtual controller that you have in there. Herman says, my assignment 1 had a virtual joystick. That's perfectly fine. You can do that. And you can do that here for as well if it makes sense for you, right, for your game. Okay. Some other suggestions, right, when it comes to virtual controllers, make sure that the 8 directions of the compass are specified to give us a player the sense of where it's going to be. Make sure your joystick snaps back to the center, just like a regular joystick would, or create almost like a little dead zone. Again, if you download an asset from the Unity Asset Store, it does a lot of this for you, so you don't have to worry too much. Make the visual of your joystick as big as possible without obscuring gameplay. So this is kind of a trick to do as well. You don't want your user interface to be too big. You want it to be unobtrusive and only kind of show up when you need it, right? So another trick would be don't show your joystick at all. And when the player touches the screen, the joystick appears where their fingers are and allows you to move your character in the direction you want. There's a lot of stuff like this that I've seen. Again, it really depends on what your mechanic is going to be and what you want to allow the player to do, right? The other thing is keep your joystick and buttons away from the edge of the screen so the players don't miss by sliding off the device. And even better, mark off zones on the screen dedicated to a single action like moving left, right, jumping, or crouching. So you might have some kind of zones or little buttons that you can press at the same time as you're moving your joystick, okay? So some things to do. What's really difficult for this for us is simulating this in the emulator, right? Because we don't have multiple touch capability with a mouse. We only have almost like a single hand to do everything with, which is actually a good problem to have. Because what you can do is you can think about, okay, so how would I do or emulate this touch, right, at the same time? All right, questions around the virtual controller again, or controls. And we talked about the 3 C's, right? So we talked about character, camera, and controls. And those are the 3 C's of your mobile game design. Moving on to nuts and bolts of mechanics. So when we talk about mechanics, depending on who you talk to, mechanics might mean different things. Examples, if I talk to board game designers, mechanics might mean something like the turns, action points, resource management, bidding, even rolling the dice, right? But when we talk about for video game designers, mechanics are usually around how the player moves, right? And what they're able to do. But there's also mechanics that are outside of what the player can do. For example, the mechanics of moving platforms, opening and closing doors, pushable blocks, switches and levers, cranks, slippery floors, conveyor belts. There can be a lot of things that can happen outside of the player, that you can do as well. So what about platforms? Because we're talking about platforms and this because you're making a platformer. Well, let's take a look at the platforms primer. And we can really call this the platformer primer because I like to call it that instead, I think. So the platforms primer looks like this. There are floating platforms. Here's pick one of these three for your assignment 2. Okay, so in addition to a static platform, you can have a floating platform where it goes kind of up and down a little bit, a moving platform horizontally or vertically, right? Something that flips to create stairs, flips to reveal a hazard, expanding or shrinking, right? Tilting platform, an exploding platform, a Ferris wheel platform, bouncy platform, tipping platforms, right? Collapsing platforms where they break up, scrolling hazards on the platforms that come towards you, something that you can roll on the platform like a minecart, some kind of chasing hazard that comes at you, a hazard that when you're a platform that moves into a hazard, or some kind of pendulum where the platform kind of moves in a pendulum motion, an extending or retracting platform, so different than an expanding and contracting one, or a growing platform, right? So where you have kind of like a magic beanstalk, right? Some kind of swinging platform, a rope bridge, a sinking platform, a smashable platform, a switch activated platform that basically allows you to move the platform back and forth, right? And kind of traverse across the platform, and a platform that has a weight balance, which is similar to a tipping platform. Choose 2. Sorry, did I say choose 2? Choose 3. Choose 3. All right. So yes, yeah, you made a, you did a platformer in your physics engines, but pick 3 of these platforms that you're going to create in 2D. Again, using the Unity, game engine. All right. Other things you should consider are doors. Lots of different kinds of doors. We have doors with knobs, doors that require some combination, doors that kind of open from the bottom and the top, or portcullis that kind of comes down. And how do you activate those doors? You might have switches and levers that open the door. You might be able to get to those switches and levers from different platforms, as an example. So you have to climb around, get to that platform, turn on the switch, go to the door. There might be a timing where the switch resets or the door closes, right? And this is similar. You can also use switches and levers for activating and deactivating platforms or the effect of what the platform is having. So example, the floating effect or the moving back and forth effect or the growing and shrinking effect. Turn them on and turn them off. And sometimes all these little options can create the puzzle that you're looking at creating if you're making a puzzle platformer or making it difficult for the player to navigate your level in certain places. Hazards. There's different kinds of hazards. Everything from spiky pits to a toxic sewer filled with floating coffin platforms, right? It's totally whatever you want to make, and it's completely different as an example than active enemies that are chasing you. These are another way of creating challenge for the player that is part of the environment. So again, you could have some kind of spike pit or trap or some kind of block that falls on the player or all kinds of other stuff. And finally, timing puzzles. Well, actually not finally, timing puzzles is another one. You might have some kind of fire, you're waiting for it, right? And then when the fire's gone, then you cross over and you move into the next part of the platform. And the last thing is props. Lots and lots of props. So your level might look really empty. Let's say, for example, you're making a level that looks like some kind of mansion, right? Or you're making a post-apocalyptic platformer that you're deep inside a pit or a sewer, a sewer system that you're trying to climb out of, right? Underneath a post-apocalyptic or futuristic city. You want to try and get out of the sewers. That's your goal for the level. And you might have props in there that make sense. Things like barricades or some kind of broken items or whatever. And these are in addition to all the platforms we talked about earlier. All right. Any questions around our platformer primer? Because again, remember what I said in assignment 2, part 1, choose, in addition to your static platform, 3 platform mechanics. So 3 of these that I'm looking for you to choose, 3 of them. I think the easy ones, if I was going to mark down the easy ones to do, to make your game a little bit more interesting, and some of this might be a little boring. I mean, this one is super easy, right? All you're doing is moving this up and down, up and down, up and down, right? To create that floating effect. This one is really easy. This one is easy, right? Because you're just moving this one to the right and this one up and down. This is not so easy. There's some mechanics around making this work, but it can work. Exploding platforms are totally easy. That's easy to do, right? So with a platform will slowly tick or change color and then finally explode with the particle effect. Collapsible platforms, really nice and easy. That you can do. Expanding and shrinking platforms, easy to do, right? And so I'm just talking about the easy ones. Let's go to the next screen. And also other things that can be easy as this one, some kind of moving. You're on a platform that's moving, but you're moving into a hazard. That's totally easy. Extending and retractable platforms, easy to do. Weight balance can be done, right? You can do this one, but it requires to create another kind of pivot in Unity, right? And syncing platforms, more difficult to do, but this is not so bad. You just requires 2 pieces, the switch and the platform that moves back and forth. So again, there's some easier ones to do, and there's some that are harder. Example, this might be a hard thing to do, to pull off, to make it look good, right? And to time it properly. Smashable platforms might be okay too. That's just destructible environment. All right. But yeah, there's some harder ones compared to the easier ones. So again, select 3 and add them into your game design. Questions around platforms and the platformer primer? Any questions at all? Herman says, not even Metroid has this many. Yeah, well, I think we've tried to capture every kind of platform you can possibly think of and add them in. I don't expect that you're going to have this many inside of your game. All right, so that's why I'm asking for you to select 3. Okay, great. So you've got this. Part 2 to this whole thing is, there's so many, Kira. There's a lot of them that are missing from here. Gravity, but these are a lot of them that you can think of. Think about 3 that you want to choose. All right, let's move into the next piece, which is going to be our Unity game. So what I want to do is I want to start off with a brand new example project for us to work on for platforming. So let's set that up right now, and then we'll take a short break and come back and actually do it. So let's do the setup piece. So I'm going to make a new project. Okay, it's going to use, again, 2021 19F1 as the starter. I'm going to use the 2D mobile core template. That's what I'm going to use. And I'm going to put name my project Game 2014 in the fall 2021 semester. And we're going to call this Lab 6. Why Lab 6 and not Lab 5? Don't know. I missed Lab 5 and I think I went to Lab 6 right away. So Lab 6 is what I'm going to go with. Okay. And let's make sure that it's pointing in the right place. So I'm going to go into GPC, Game 2014, and it's going to be here in this folder, right? So Lab 6, and I'm going to create my project. Now you're going to bear with me while I do this, because just like when you make your first project the first time, it takes a bit of time to import the default assets for this one to start your process going. So let's do that. Nope, not Lab 6B, because the last time I did week 9. So I kind of did something different today. I don't know where my brain's at. I think I haven't eaten enough. I'm like you. I haven't taken a break last week too much. So lots of stuff going on. But yeah, I probably should have made it Lab 6B if I had a Lab 6A, which I don't. So do I. But then sometimes for some people, if it's too long like that, Herman says it'd be nice if we had 2 weeks for reading week. Yeah, I agree. But then it's too long and then we lose track and we don't want to come back. Sometimes that happens too. So that's not something we want to do. And, That's why it's the way it is. All right. We're just going to wait for this to turn on. Yes, I agree. I think that one of the things that we want to plan, I know that it's a rule in some places where you're not allowed to give students any kind of work over their your intersession break, and the reason for that is because exactly what you're saying, uh, Kira. Because once we give someone work to do during intersession, then they don't really have a break, right? And although in your mind you're thinking, well, they have lots of time, it's like 2 weeks instead of 1 week, but actually they're working on your stuff and they have no time off. And sometimes we use intersession break to, at least I do, to recharge and reset and do all those fine things. All right, so again, I'm starting off with a mobile layout, that looks like this. Notice that I'm using Tom's 2D mobile layout, which is landscape. That's what this is. And I have chosen a simulator for this that is in landscape orientation mode. Or I've also programmed my game so that it works so that the landscape mode has been selected. So I've created a new kind of view, if you will, which is a landscape mode that is 3040 by 1440. Okay, so that's the first step. I'm going to start with this mode, so we're not going to require touch input, just so that I can prototype my game. That's the mode I'm going to start in. Again, like normal, I have a sample scene. I'm going to change my scenes to main. Start this off. We're just going to set, this is all the setup part, guys, right? Main is the start scene. I'm going to rename my scenes to scenes. There's scenes. I'm also going to add a folder for scripts. Again, you can add your folder in there. I know I'm going to have some materials, right? And I'm also going to have some sprites, because this is a 2D game. So those are the things I want to start with. I'm also going to get you guys to download 2 projects, right? So from the Unity Asset Store. So let's go there. In the Unity Asset Store, I want you to search for Sunnyland, and there are 2 projects that you can download for free. One of them is the Sunnyland project, and the other one is Sunnyland Woods. So please download these 2 projects and install them in Unity. So what that looks like is, for me, when I add them to my packages, I can go to packages that I own, my assets, and I can kind of search for Sunnyland. If I go just Sunny up here, then you're going to see I have 3. I have Sunnyland, Forest, and Woods. I'm only going to take Sunnyland and Woods. Let's add those in. So Sunnyland, import, and then Sunnyland Woods, and import. Okay, so a couple of projects, right? And what this does, it gives us enough assets to start working for the second half of semester. Herman says, can we use Sunnyland for our assignments? Yeah, that was going to say that. The answer is no. So this is the only thing for Sunnyland that you cannot use for your assets. Please use something else. All right, so Sunnyland is off limits. These are my assets that I'm using for my tech demo. You use your own. Okay, lots and lots of them out there. But I think Sunnyland is a good one for me to practice with for you guys. Sorry, Herman. All right, so now that we've downloaded those assets, as an example, again, this is all the setup that we want to start going with. I want to set up our world, and the way to do that is I want you to right-click, and we're going to go to 2D Object and create our new tile map. We're going to make a rectangular tile map here. We're going to use this tile map name is going to be the platform layer, right? And our grid, I'm going to rename to our world. So world and platform layer, those are the 2 things, okay? And if I click on my platform layer, I'm just going to kind of make this smaller here. I'm going to open up my tile palette, and you can see that I don't have a tile palette created by default. There's different ways of doing this, right? But I want to click Create Tile Palette, where I want to make the name of my tile palette Sunnyland. So for the first one, I'm going to make 2, right? This is the first one. I'm going to click create. It's going to ask me where do I want to do this. I want to go into assets and then make a new folder. Oops. How about I don't make a new folder, delete. In sprites, I'm going to make a new folder called Sunnyland, or maybe tile maps. Right, there we go. And in tile maps, I'll make a new folder called Sunnyland. How about that? We're going to have a bunch of sprites. And while we're at it, let's make another one called Sunnyland Woods. Okay, so we're going to make 2 of them, right? But here we want to go into Sunnyland itself and select that folder. So that's where my tile palette prefab is going to appear. If I go to sprites now, and if I go to tile maps, I can see that I have Sunnyland, and inside here I have a prefab called Sunnyland itself, which gives us some information about the grid, as well as some palette settings defaults. So that's kind of a prefab that I get, and something that looks to me like a scriptable object. Cool. So that's what's in here, but our tile map is kind of empty, and it says the active tile map is now the platform layer. That's okay, but I want to drag and drop our sprites or texture assets in here, and I can do that by going down to Sunnyland Artwork Environment and clicking on Tile Set Sliced. Notice our tile set sliced here. By the way, you can bring this up. If you don't have it, if it's like this, you can bring it up so you can see all the tiles. And in tile set sliced, you can see that my pixels per unit is 100. Let's move this to 16. And let's change my, my maximum size to 2048. And our resize algorithm to bilinear. When I've done this, I want to click apply. There we go. And I want to drag and drop my tile set sliced into the palette over here like so. And it's going to ask you, where do you want them? Well, obviously I want them inside assets, sprites, tile maps, Sunnyland, and click select folder. And this is going to split up all these things and create a bunch of tile assets that are here, like so. So that's our first tile palette. And if you notice inside of sprites, tile map, Sunnyland, you're going to see that they've sliced every single one of these. And so you can see each of these items. Okay. Nice, nice, nice. Excellent. Let's make a new one. So to make a new one, I'm going to, again, hold down this little drop down, go to create new palette, and change this name to Sunnyland Woods, and create that new palette. Okay, it's going to ask me, where do I want it? I want it into Sunnyland Woods, and select that folder. It's going to make that new prefab. And just like I did before, I'm going to go into Sunnyland Woods as our assets we've downloaded, going to environment, going to tile set sliced, change the pixels per unit to 16. Again, if you don't like the size, you can change to a different size. But then you have to change the tile size as well in your world. I think 16 works fine for me for this particular asset. And I'm going to change the resize algorithm to bilinear. 2048 is correct, and click apply. And then drag and drop my tile set sliced into my tile set. And now it's going to ask me, where do I want this? I want it into Sunnyland Woods, where it's going to create all the assets that I need for my tile map. Okay, so pretty straightforward process, right? You guys have seen it before. This is not something new for you. In fact, this should be a review. I might have done it differently than Joss, but at the end of the day, it's the same. Okay, so now that I have those palettes, right, if I click on the platform and I click open palette, I can select the type of palette that I want to use, and we're pretty good to go right here. Okay. Next, let's set up our project parameters, right? Let's save a project and file. So save project, and go into build settings. And I want to create our build settings for PC, Mac, Linux, Android, and WebGL this time around. So PC, Mac, and Linux, let's start there. We're already there. Let's go into player settings. So in our player settings, I want to do some switching around, right? So our resolution and presentation is not going to be full screen window. So if I want to check locally with just building a local build, again, no requirement to be on WebGL, or if I don't want to go onto the emulator. I want to test locally first. Then I can change this from full screen to Windows. And I want to select a size that makes sense. Now notice that my landscape is 3040 by 1440. I really can't put that as the size of my screen because it's probably too large for some people. So let's put a kind of a aspect ratio similar to this inside of our screen that we're going to use for WebGL as well as our Windows PC Mac Linux standalone build. So I'm going to pull up my calculator. And I'm going to take kind of that number. So again, something like 3040 divided by 1440. And I'm going to say something like it's 2.1 times, the width compared to the height, right? Height is, again, 1440, but the width is, something like, 3040. So much wider than taller, right? That's the kind of way of doing it. The other way to look at this is, if I already have the width that I want to use, right? And I know that I can go as wide as something like 1024 or even, 1920 would be the highest, the highest width. Is 1080 correct, right, for that one? So what's the ratio of 1920 by 1080, right? What does that look like compared to my phone? Well, it's different, 1.7. I need to bring this up to 2.1, which means I need to make the height much smaller than 1080 if I'm going to use 1920. So if I have the width and I want the height, it's the other way around. I would say something like, well, what about if I took 1440 divided by 3040? So 1440 divided by 3040 as an aspect ratio gives me a number that's 0.47 something. So that's what I want to multiply by 1920 to give you the right number. So multiply by 1920. So I'm going to have a width of 909. So 909, let's say 910. And 1920 by 910 is the same ratio as 3040 by 1440. That's the width, and this is the height. I made a mistake earlier today. I did it kind of the other way around, but this is the right ratio. Okay? And this is okay for a PC. Okay? And let's keep going. So that's the first thing, resolution. Next one is other settings. I want to move away this time around from gamma color space to linear. Let's move that. Let's make that change. That's a different, more realistic color space than what we've used before. It's a little bit more computationally expensive though. So we're going to use this to make our colors more vibrant and closer to what we want. And in next semester, we're going to use linear all the time. Awesome, it's done. Down where it says the name, the bundle identifier, let's uncheck this. And what we want to do is at the top, change the default company so that it is the name of your team or yourself. So for me, it's George Brown College, right? And when I scroll down, let's make the version number 0.01. How about that? So that's our first version. We might not get to version 1 or anywhere near it, but that's okay. And then down here, we can do is we can click on this and we can have the correct name. So we can say ca.George Brown College, GAME2014. And what we want to do is you can put this in there or you can put dots in between. Doesn't matter. The other thing is our scripting backend should be IL2CPP for all of our backends and .NET 4, right? And that's really all you need. Let's close this off and go back to PC standalone. It says cannot build player while editor is importing assets or compiling scripts. It's going to do a bit of a script recompile. Let's go back to the next one. So that was PC Mac Linux standalone. So if I want to build for this, I've set up my project so I can build in the right, kind of to make it look like a phone is what I'm kind of making it do, right? Same thing with WebGL. That's the next one I want to do. So again, let's switch platform. So WebGL is another option. We can test and we can actually share with other people. I can share my code with my friends. I can have them evaluate what it looks like first, get some more input from them, have some testers test it without owning a phone, and so on. Find the fun first and then add your control scheme for your phone after. right? Again, that would change stuff, so beware. But we also want to be able to support multiple platforms here. It's a little bit different than what we did before. I'm going to click player settings. And again, what I want to do is my color space linear is okay, because once I switch it, it switches for all of them. But my auto graphics API for WebGL is not. Let's uncheck this. And let's remove WebGL1. We will not support WebGL1 because linear does not support WebGL1, only WebGL2. Again, from an API compatibility level, we want to go .NET 4. And on the bottom, the one thing we want to change for WebGL is our compression format, which should be disabled. So that is our WebGL build. Yeah, I know. It's awesome, Kira. That's why I use WebGL as well. And the last one is the Android build. All right, so we've kind of done all of them. So 3 builds. Let's go and switch platform again. And this is getting our project ready for testing. We're going to do the same thing next semester. I'm just getting guys into that now so that we're ready to go. All right, and it's converted everything. Yay. Cool. Creates additional versions of our shaders and our script. Luckily, we don't have any scripts right now. And player settings, if you notice, if for Android, well, our resolution presentation is full screen window. One thing we will not support is portrait for this game. So no portrait support, only landscape right or landscape left. We're making a platformer. And on the other settings, let's make sure that they're set up correctly. So we want our company or our bundle identifier to be the same. This should be .ca 001, bundle version code 1. Android 4.4 KitKat is the base. And our scripting backend is IL2 CPP. And our API compatibility level is .NET 4. We'll let that recompile down there. Awesome. And when this is done, we can also check off ARM64, which is something that needs to be done. If we scroll down, we can see that everything else is left as is. Okay, so we've done all of them. And now we've stuck with our Android build. So we've done all those 3 builds: PC, Mac, Linux. 4.4 KitKat is okay, yes, to start off with. We've also done, because that means that we have a wide compatibility range. We can also update that if you want to something else. Not many phones run 4.4 KitKat anymore, but it's okay. And WebGL and PC, Mac, Linux. Those are the 3 builds. Great. So we've got our builds done. And now what I want to do is file, save project. And let's exit from Unity. Now, someone asked me earlier today, they said, why are you exiting from Unity? Why don't you just go straight into, Gitkraken or your other thing and just do it straight from there? And I've found that when I've done that, I've kind of mentioned this before, right? Oh, by the way, we probably have to do this for WebGL. WebGL should be this same ratio. One thing I forgot to do, I'll go back and change that in a second. My problem with doing it like that is you have a lot of meta files that have been added in. So let's add a new project like before. So I'm going to say start a local repo. I'm going to be targeting GBC GAME2014, but I want to target Lab 6. So I'm going to grab that name and put it here. And then let's add a Unity gitignore file as well as an MIT license. Right? And then let's click create repository. So that's going to create my repository, but I have a bunch of items, right? And by the way, here's something. I know 100% that this is wrong, right? I know this is wrong for a bunch of reasons. The main reason being that my repository is a repository that's inside of a repository. Take a look at that. Look. I know this is wrong. So how do you fix this problem? Because some people had this problem when they submitted to me last time. Well, it's pretty easy. One, let's take a look at let's leave this thing for a second. And let's go back and take a look at my files. So I'm going to pull up my desktop. And I just made a mistake, which is good because I can fix it with you guys. So this is what happens if you just do that. So Lab 6 has a Lab 6 thing in it. And inside there, you have your git ignore and all that stuff, right? And that's not what we wanted. We didn't want this at all, right? We wanted is for it to be here. That's why we had to do it the other way. So let's delete this and just do one more time. So again, I've deleted this one. And let's do this whole thing one more time. So I'm going to start a local repo. And it is pointing at Lab 6. That's not what I want. It should point at GAME2014. And what I should do is grab Lab 6, right? Copy it, cancel. I selected it by accident. And that's when I had that issue. There we go. Now this is different, and you can tell immediately because I have 1,084 files. And that's how I know it was wrong. Stage all changes. And then add a new commit that says added project files. So that's the difference. Now I've done that. I want to push right to GitHub, and I want to select George Brown College. Again, I'm going to make this public, Lab 6, right? But you can make it private as long as you include me and include both of my accounts, please, if you can. So create, remote, and push for local references. By the way, notice that it also supports Bitbucket and GitLab, and I'm okay with any one of those. Yay, done. Let's go back into Unity and fix that problem that I forgot to fix. So what I meant was, yes, we had a nice layout for my calculator. I used a ratio or an aspect ratio for my machine for PC, Mac, Linux, but what about for poor WebGL, right? So if I look at player settings and if I look at WebGL in my resolution presentation, is it correct? The answer is no. It's 960 by 600. If 600 is the largest type of screen, then we could adjust 960 to be the right width, right, based on the height. What we need is the same ratio that we plotted here, 1920 by 910. So 1920 by 910. Now this is quite large, and if we're going to do a WebGL build that's 1920 wide, sometimes it's too wide for the browser. So this ratio we want to maintain, right? So again, looking at 3040 by 1440, right? We want to say that take 1440 divided by 3040, and let's think about a reasonable width that I want, like 1024, right? So multiply this by 1024. So 1024 by 485 is what it should be, right? At the very width. So 1024 by 485, which is about half of what we had there. Okay, 1024 by 45. This is different ratios, but I want to point this out because I find that making it too wide, like 1920 sometimes is too much, right? For a web presentation view. Okay, so that's good. That's all you have to do. Save and file, save project. We're not building to WebGL right now, but it's good to keep track of all those things, all those changes before we move on. All right, that's good. This is our setup. Our setup is done. We put it up on GitHub. You've got a starter. We've done it together. We've got all of our assets ready to go. Let's take a short break. It's 4:30. Let's come back at 4:40, so 10 minutes, right, approximately. So we'll take a break for 10 minutes. So on break, approximately, let's say, back at, let's say, 4:45. Okay, so that gives us enough time to finish off everything else we want to do. Okay. Questions? Well, let's maybe it's too long. 4:41. 10 minutes. All right, let's take a short break. I'll be back at 4:41. I'm going to stop streaming right now.